Okay, so this is a problem out of the packet that I gave you guys. So we have C6H12O2. First thing I would do is determine the degrees of freedom. So we have 6 carbons times 2 plus 2 minus 12 hydrogens, all divided by 2, and that gives me 1 degree of freedom. So this 1 degree of freedom could either come from an alkene or a carbonyl. I would not do an alkene because here you have 2 oxygens, right? And also we have a peak at the 4, which means we have an ester. So I would first draw my ester group right here. And now we have 5 remaining carbons to place. Well, we know that we have 2 groups of 3 and 2 peaks. So we have 3 and 2 here, 3 and 2 there. Or it could be 3 and 2 here and then 3 and 2 there. So you don't know which peak goes with which peak, but you do know that you have the 3 and 2s. That means you have ethyl groups somewhere. Okay, so I would put an ethyl group right on the O, and I'd also attach the remaining carbons on the other side. So we have 1, 2, 3, 4, 5, 6 carbons. Or you can put the shorter ethyl group on the actual carbonyl and have the longer one on the oxygen. These are very similar, but they're also they have important differences. And esters are really difficult on NMR, but hopefully I can clear some stuff up. So how do you figure out the right answer? Well, let's look at the NMR. We see this really complex splitting right here, right? It's like 1, 2, 3, 4, 5, 6 peaks, I believe. So it means it's around a lot of hydrogens. So these two hydrogens have to be the ones that are right here, because these are the only 2 hydrogens that are around so many other hydrogens. Okay? So we got that one out of the way. Now let's compare these two. So this one has 1, 2, 3, 4 peaks. Okay, so 4 peaks means it has to be next to 3 hydrogens. Okay, so our remaining areas are, so we have these hydrogens are next to 3 hydrogens over here. Here you have no place left over. So it's either going to be this short ethyl group right there. Okay, and then clearly these last 2 have to be the one that's over here and over here. So these 2 groups, these hydrogens are going to be the ones that are next to only 2 other hydrogens, because this splitting is only 3 splittings. It's a triplet. The 3s we don't care because they're on the methyl groups. The biggest distinction to determine is, notice how this group is so far downfield, right? So it's more deshielded. So what causes this deshielding is this oxygen. Because oxygen is highly electronegative, it's going to pull electron density away from these 2 hydrogens, making this more downfield. So that's why this is the answer. Now, the splitting, the NMR on this one would have, so we've determined that these 2 groups of hydrogens are these 2 groups of hydrogens. So because on this molecule they are closer to the oxygen, these 2 groups, if this had its own NMR, would be further downfield, and then these hydrogens would be further upfield. So these would basically be flipped. So to wrap up, because these 2 groups of hydrogens are further downfield, that means they're directly attached to something that's electronegative, which is this oxygen. And so yeah.